In this presentation, we're going to explore VPC, or Virtual Private Cloud. VPC came out of the need to secure resources. AWS Classic is really the Wild West. There's no way to effectively cordon off an entire stack of resources, and there's no control of networking. Stuff like subnets, routes, network access control lists, and ingress and egress control. EC2 Classic was unable to satisfy many of the network security or NetSec requirements. Let's take a look at EC2 Classic, which is non-VPC. We have customer 1 spinning up 2 EC2 instances. These are each given a different B-class subnet. This one's on 10.1, this one's on 10.10. Customer 2 comes along and spins up 2 assets of their own, and these also get put on different subnets. Customer 3 comes up and gets different subnets as well. One of the problems we have here is that customer 2 and customer 3 can ping each other on these private IPs. Customer 3 may decide to put security groups on their machines, and in doing so, they could accidentally lock off access to each other. Each of these machines also has direct access out of the network into the internet. If instead customer 2 and customer 3 created a VPC for each of their own assets, customer 2 can choose a B-class network, such as 23.8, and launch all of their machines inside of that network. The VPC itself is secured, so there's no way to get in here. In fact, this customer wouldn't even need to have security groups between their machines. Customer 3 can provision a 7.8 IP address range with 2 subnets that can talk to each other on that range. Each of these VPCs have access through a gateway, not through the individual machines, and there's no way that these 2 customers can ever see each other's stuff. VPC allows for logical isolation of your resources, both from other customers and from internal divisions or application tiers. It gives you control over address spaces, subnets, route tables, and NATs, or network address translations, which we'll talk about in a bit, network gateways, VPN, and internet. It also allows ingress and egress security groups, and you can have multiple NICs, or network interfaces, which are known as elastic network interfaces, on VPC EC2s. It also allows for dedicated hardware with EC2 only. Here again, we see 2 customers, C2 and C3. They've isolated their resources from each other, and customer 3 has isolated their resources from individual divisions or application tiers. Many times when you're deploying an application, the NetSec requirements will require that, for example, the database is on a separate subnet. VPC allows for this, whereas Amazon Classic does not. VPC gives you control over your address spaces. You can provision up to an entire B class of IPs if you like, or a /16, which is 65,000 IP addresses. Any address space provisioned in VPC will be available to the subnets, and VPC addresses don't change when the EC2s are bounced. Public-facing IPs will still need to be internet routable, but you can use elastic IPs, and you must route through an internet gateway. VPC also gives you control over subnets. Subnets can be provisioned in a single AZ. They cannot span AZs. You can have 200 subnets per VPC, and in VPC, you're going to think of subnets the same way that you do as AZs. Autoscaling groups will span VPC subnets and not AZs. The minimum size of a subnet has to be a /28 or 14 IP addresses, and the maximum size of a subnet can be the size of the VPC itself. When sharing with an outside network, like bursting from corporate, be careful for IP conflicts. VPC also gives you control over route tables and NATs. Route tables basically specify which traffic goes down what line, and it depends on the sender and target. For example, you can say that traffic bound for the corporate IP address goes down the VPN, and traffic bound for the internet goes down the NAT. NAT, or network address translation, basically lets machines hide on a private network, but still be able to get out of the network to resources on the internet. AWS provides a NAT instance that you can deploy for this purpose. VPC also gives you control over network gateways. You have an internet gateway which allows VPC resources to access the internet, and it's the only way for these resources to access the internet. It can be connected and disconnected programmatically. For example, when you're doing patch updates on your EC2 servers, you can connect the internet gateway, pull down your patches, and then disconnect the internet gateway once you're done. There's also a VPN gateway, or VPG. This is a hardware VPN solution that mates with your on-prem VPN. Your on-prem has to obey BGP, or Border Gateway Protocol. Most of the major VPN appliances do. These can be used to treat the VPC as an extension of corporate. It comes at an additional hourly cost, and software VPN is also possible. I've deployed OpenVPN many times, and I can recommend it as an excellent solution. VPC also gives you control over both ingress and egress security groups. This is only for EC2, but you can control both inbound, such as EC2 Classic, and outbound. This can be used, for example, to allow your EC2 to access package repository, but nowhere else on the internet. Additionally, network access control lists can allow or deny traffic into and out of the subnet. VPC gives you control over multiple NICs. A single EC2 server can now have more than one network interface card. The number of network interfaces card is dependent on the instance type, and generally the larger EC2 instance you get, the more NICs you can have attached to it. These are also known as Elastic Network Interfaces, or ENIs. They can be added and removed to a running instance, and they come at no additional cost. VPC gives you the option to provision dedicated hardware. EC2 instances launched into a VPC can run on dedicated hardware. This reserves the entire physical server for a single tenant. It is very costly at $10 per hour, but it can allow for strict compliance with any multi-tenancy restrictions or laws that your application may have to abide by. VPC comes with several limitations. Only select resources can be launched into the VPC. Currently, that includes ELBs, with support to balance between the web app tier only in the VPC, EC2 as well as EBS and autoscaling, RDS, or Relational Database Service, and Elasticache, or the Memcache compliant in-memory cache. You'll want to launch all of your resources either together inside or outside the VPC. If you try to put half in and half out, the network lag in and out of the VPC will seriously affect the running speed of your application. VPC also provides no multicast or broadcast support, the same as EC2 Classic. VPC has a lot more limitations. You can only have 5 VPCs per account per region, 200 subnets per VPC, 5 VPC EIPs, or elastic IPs, per account per region, 1 internet gateway per VPC. The number of ENIs per instance, again, depends on the instance type, and subnets can only belong in a single AZ. To set up a VPC, you first create it by choosing a reasonable IP address range, being careful not to conflict with an IP address range that corporate has. Then you choose the AZs that you're going to span. You then create subnets, route tables, network access control lists, and launch your assets into the VPC. You can connect an internet gateway and a virtual private gateway, and consider programmatically connecting and disconnecting the internet gateway if you can. VPC has a lot of use cases. Probably one of the most popular is bursting internal capacity into AWS, using the same address space so that EC2s look like they belong on your network. Again, please be careful provisioning your VPC and subnets to avoid IP address conflicts with your corporate address space. And be aware that data transfer between corporate and AWS is using public internet. This will both be slow and expensive, but you can alleviate this with the Direct Connect dedicated connection. We don't cover Direct Connect in this course, but you can find information about it on the AWS website. The thing I love about VPC is that it's extra free security with very little complexity add. Pretty much these days, I launch all client configurations inside of VPC. VPC is also great for products that require fixed IP addresses, such as many Windows products, and it allows for compliance with strict regulations such as HIPAA, Sarbanes-Oxley, and so forth. The pricing on VPC comes at no extra cost. You're only charged for resources you spin up inside the VPC at their normal rates. Dedicated EC2 instances are available but expensive. You have the option of paying for a hardware VPN, and you also have the option of doing dedicated tenancy. In summary, AWS Classic is the Wild West. VPC allows for controls of subnets, routes, NACLs, both ingress and egress. It also allows you the ability to satisfy many network security requirements. You can use an internet gateway and a virtual private gateway to allow access to the internet in corporate, and it's free to use.